Hi guys, welcome to In 5 Minutes. Now we will be understanding disk scheduling with the help of a sum. Consider that we have a work queue given 23, 89, 132, 42, 187. The disk which is presented to us is of 200 cylinders. That means 0 to 199. And currently disk head is located at 100. So representing the same stuff would look something like this. Now in this particular given thing, we are considering that time goes down. So considering the first one, first come first serve, let's try to understand that head is at 100th location. In first come first serve, we simply follow the sequence in which request has occurred. In current case, that simply means from 100 head would move to 23. From 23 head would move to 89. From 89 it would move to 132. From 132 it would move back to 42. From 42 it would finally move to 187. So let's calculate the seek time for it. In order to calculate seek time, we should always remember that initial position of the head was on 100. So for the first movement, that is from 100 to 23, it would be 100 minus 23 plus for the next movement from 23 minus it has moved to 89, so minus 89 plus for the next movement from 89 it moved to 132, so 89 minus 132 plus from 132 it shifted back to 42. So 132 minus 42 and finally adding from 42 to 187. So 42 minus 187. If we can carefully understand and see, we are taking mod. By saying mod, we are not considering plus minus, we will be just considering the seek time. Performing the mathematics, we would finally have 77 plus 66, 43, 90, 145. So the final total seek time which we had was 421. If we want to find out average seek time, that is 421 divided by total number of requests, that in our case it is 1, 2, 3, 4, 5, which would give us 84.20. This is for first come first serve. Let's go with the remaining. Now the next we are working with SSTF. This is shortest seek time first. Now considering we are at 100, we would need to go to the nearest 200. So we have two options to go through. One option is 89, another is 132. If we count it with mathematics, 89 would be much closer. So now we would be first going to 89. From 89, the nearest is 42 or 132. If we count again, the next nearest from the 89 would become 132. So we'll go to 132. So now from 132, the nearest is 187. Now since there are no other options left, we'll come in the reverse direction, and this time we would be going straight away to 42. And from the 42, only one thing left and nearest is 23. That means even in this algorithm, we started with the nearest, shifted to second nearest from the current location, then went to 187, then to finally reaching to 42 and finally 23. If we calculate the seek time calculations, which would be starting from 100 minus 89 plus from 89 to minus 132 plus from 132 to 187 plus from 187 to big jump to 42 and from 42 to the final 23. So the total seek time comes out to be 273 If we want average by 5, it would be 54.6, much better compared to earlier, which was coming out to be 84.20. This comes out to be 54.6. But we still have other techniques to talk on.